So this video is on the fourth worksheet of our linear programming. And this is the second problem that we did not get to in class today, but we are submitting this. So I'm going through this problem for those who might need some help on it. Okay, so Mr. Ree makes two types of wood clocks to sell at local stores. It takes him 2 hours to assemble a pine clock, which requires 1 ounce of varnish. It takes him 2 hours to assemble an oak clock, which takes 4 ounces of varnish. Mr. Ree has 16 ounces of varnish in stock, and he can work 20 hours. If he makes $30 profit on each pine clock and $50 profit on each oak clock, how many of each type should he make to maximize his profits? So on this, first thing we want to do is decide on what we should have as our X and Y. And so looking at this, you want to ask, what are they looking for? How many of each type? So I'm going to have my pine clocks, number of pine clocks, and my oak clocks. That's going to be my X and my Y. So let X equal number of pine clocks and let Y equal number of oak clocks. Then I need to figure out what my objective function is. And my objective function is what I'm trying to maximize or minimize. So in this case, I'm trying to maximize profits. So I want to look for profit. So $30 profit on each pine clock and $50 profit on each oak clock. Okay. So I am going to have my objective function. And again, it is going to be on profit. So I'm going to go P equals, and it's $30 for each pine clock plus $50 for each oak clock. So that's going to be my objective function. And again, what this is doing is we're trying to maximize profit. Okay, so that's my objective function. That's what I'm going to plug all my vertices into. Okay, constraints. These are all of our inequalities. So for this, as I'm reading over this, it looks like we have time and varnish. So it takes 2 hours to assemble a pine clock. It takes 2 hours to assemble an oak clock. And there's 20 hours total. So that's going to be a constraint or an inequality. We also have varnish. 1 ounce of varnish for a pine clock, 4 ounces of varnish for a oak clock, and we have 16 ounces of varnish total. So when you do your constraints, if they do not give you a lower bound, we will never have a negative amount. So we're always going to say X is greater than or equal to 0 as 1. Because we cannot have negative pine clocks, but we also cannot have negative oak clocks. So Y has to be greater than or equal to 0 also. Okay, so that's just saying that we can't have negative amounts. Now, my next one, let's get rid of that. My next one is going to be, okay, so my next one is going to be, let me do the hours. Okay, so it takes 2 hours, so 2x for my pine plus 2y for my oak. And we only have 20 hours, so I'm going to go less than or equal to 20. Now, I'm noticing that everything here is divisible by 2. So I could really divide everything by 2 and go X plus Y is less than or equal to 10. So I could also have that as my inequality. And this one was on hours. Then I'm going to have one on varnish. Okay. So I have 1 ounce of varnish. So 1x or even just x. I don't need the one in front. Plus 4 ounces. So 4y is less than or equal to 16. And this is on varnish. So now we're going to plot these, okay? So first thing I'm going to do is I am going to just label this. This is going to be number of pine blocks. And this one here, I'm going to start it here. I'm going to change it in a second. Number of oak blocks. And I'm going to come up here and come to this, and I click on it, and it'll turn it for me. Okay. Made that so big. Okay, and so in terms of this x is greater than or equal to 0, y is greater than or equal to 0, basically it means that we're going to be in this quadrant, okay, quadrant 1. So let's just say I have a vertical line here. Here, let me start again. I don't know what I'm doing. So if I have a vertical line here, I'd be shading to the right of that. And here I have my horizontal line. And just so everyone understands, this one here is my x is equal to 0. That's what that line is. And this one here is y is equal to 0. And at this point, I would be shading everything in this quadrant, everything to the right of the vertical line and above the horizontal line. Okay. So now for hours, I did convert this one right here to this. You could get this in y form and go y is less than or equal to negative x plus 10 and start at 10 and go down 1 over 1. You could also put 0 in for y to find your x-intercept, which would be x equal 10. Put 0 in for x to find your y-intercept and get y equal 10. So my x and my y-intercepts are 10. So if I do that, I'm going to start at 10 and go down 1 over 1, down 1 over 1, down 1 over 1. Well, I'm going to do 10 and 10, but going 10 and 10 is reduces to 1 and 1. So it's going to be down 1 over 1, which is the same as my y equal equation. And then let me draw my line. And I would be shading below, okay? So right now I would have, whoops, thought I was in a color. I would have everything here so far shaded. Now, the next one is this one. And I can get it this in y form. So 4y is less than or equal to negative x plus 16. Divide everything by 4. Divide by 4, divide by 4, and I get y is less than or equal to 1/4 x plus 4. I could also have found my x and y intercepts by putting 0 in for y, and I get just x is equal to 16. Put 0 in for x, and I get 4y is equal to 16, which means y is 4. So I could plot my y-intercept at 4 and my x-intercept at 16. My y-intercept at 4, my x-intercept at 16. And if I go down 4 over 16, that does reduce to this negative 1/4 that I got for my slope. Okay, so I can think of it either way, whichever way is easier for you to graph. So down 1 over 4, makes it a little thicker. Down 1 over 4, down 1 over 4, Oops, I think I went over one too many. 1, 2, 3, 4. Okay, and then connect these. And let me change that color. Okay, and so I would be shading beneath that one too. So my final shading is going to be everything here. And so when we're looking at this, and if I was following this, let me just kind of draw it in yellow. So if I was following this, I have basically a quadrilateral. So I'm going to have 4 different vertices. This one here is 0, 4. This one here is 0, 0. This one here is 10, 0. And this one here is 8, 2. I think I erased my time clocks. Okay. So I'm going to plug those vertices into my objective function. Okay. So let me just get my objective function again. So this one here, I'm just going to, I don't think it'll let me, hold on. So I don't think it'll let me copy it. Okay. So, 30x plus 50y. Okay. So I am going to have vertices, objective function, which is profit equal 30x plus 50y. And I'm going to take all of my vertices, 0, 0, which is going to end up being 30 times 0 plus 50 times 0, which is 0. 10, 0. So it's going to be 30 times 10 plus 50 times 0. So that's going to be 300. 8, 2. So 30 times 8 plus 50 times 2. So that is going to be 240 plus 100. So that'll be 340. And then I have 0, 4. So that's going to be 30 times 0 plus 50 times 4, which is going to give me 200. And we want maximum. So the maximum is going to occur here. It's going to be $340 profit if we make 8 pine clocks and 2 oak clocks. And so we're going to write our answer. The maximum profit is $340 if he makes 8 pine clocks and 2 oak clocks. So hopefully this helps.